A deuteron of kinetic energy 50 kiloelectron volts is describing a circular orbit of radius 0.5 meters in a plane perpendicular to the magnetic field B. The kinetic energy of the proton that describes a circular orbit of radius 0.5 meters in the same plane with the same B is to be calculated. So centripetal acceleration on a particle in a circular path is given by v square by r, and hence the centripetal force is given by mv square by r. And how is this acceleration achieved? It is through the force that the magnetic field exerts on the moving charge, which is in magnitude qvb. This gives us that the velocity is equal to the charge into the magnetic field into the radius of the circular path divided by the mass of the particle. The charge on a deuteron is the same as the charge on a proton, because the deuteron is simply a nucleus of a deuterium atom, which is one proton and one neutron. So since it has only one proton, it has the same charge as a single proton. The magnetic field and the radius of the circular path are given to be the same in both cases. The mass of a deuteron, however, is twice the mass of the proton. Why? Because the deuteron has two nucleons in it, while a proton has one nucleon in it. This means that the velocity of a deuteron is equal to half of the velocity of the proton when they are in the same magnetic field and inscribing a circular path of the same radius. So now what is the kinetic energy of the proton? We have kinetic energy is equal to 1 by 2 mv squared. So in the case of the proton, it would be 1 by 2 the mass of the proton into the square of the velocity of the proton. But the mass of the proton is half of the mass of the deuteron, and the velocity of the proton is twice the velocity of the deuteron. So this expression becomes the mass of the deuteron into the square of the velocity of the deuteron, which is twice the kinetic energy of the deuteron. And the kinetic energy of the deuteron is given to be 50 kiloelectron volts. 2 into 50 kiloelectron volts is 100 kiloelectron volts, and hence option D is the answer.